Assalamu alaikum viewers. So today we are going to solve Feb March 18 paper 1 to question 20. The diagram shows a large crane on a construction site lifting a cube-shaped load at a constant speed. A model is made of the crane, its load, and the cable supporting the load. The material used for each part of the model is same as the full-size crane, cable, and the load. The model is 1/10 full size in all linear dimensions. What is the ratio of stress in the cable in the full size crane to stress in the cable in the model crane? Okay, so let me make one thing very clear, that the model, this line is very important. Okay, the model is 1/10 full size in all linear dimensions. So this means that all linear dimensions means the linear dimensions are length, height, width, breadth, or all the measurements that we just take by the scale, or but we just measure them. We don't do any process, or we don't use them in any we don't use the process quantity. So the linear dimensions are the dimensions which we just take by measurements, and we don't find them by formula. And so the model is 1/10. If model is 1/10, this means that the full size crane would be 10 times the model. So if you were to use this thing, then it would be, I think, very easier for you to understand. So now let's begin. As we have to calculate the ratio between the stress, so the equation for stress is equals to force upon area. Now, as we are looking for the stress in the cable, so the force would be weight of the load, right? And the area. Area is actually the cross-sectional area of the cable. As the cable is in cylindrical shape, so area is equals to pi r square. And as we have to express this in terms of diameter, because mainly it's very easy to find the diameter than the radius. So to express the formula in terms of diameter, what do we have to do? We just have to replace, radius is the double of the diameter, and diameter would be half the radius. So just instead of radius, you have to write d upon 2, which is half the diameter, a square. So you will square both d square upon 4. So the formula for cross-sectional area of a wire or the cable is pi d square upon 4. And now you have to express all the you have to express all the terms in all the linear dimensions as much as you can do. Now, if you are saying about the force, if you see about the force, it's the weight of the object. Now, weight is not a linear dimension because it has already a formula. So through that we could find it. We could not measure the weight. We find the weight by the formula mainly. So the weight is equals to mg. Now you cannot further express g, but you could further express m, mass. Density is equals to mass upon volume. So mass would be density into volume, right? You could also further express volume also, as it says that the load is cube shaped. So this means that the volume was equals to L cube. L is the length or the value of one side of length of the cube of one side. Okay, so L cube, and this would be the formula for finding the volume of a cube. Now let's see how you find the ratio. Now the formula for force is